see if it's streaming. First thing that I want to say is I want to give a shout out to this guy here. I was watching some of his videos and they're extremely good. And then I made a spreadsheet here and wrote down some of the things that he talks about. And now I want to watch all his videos because they're really, really good. And he talks about SEO and explains a bunch of things really well. So I'm probably gonna follow his videos, especially the SEO video when I'm building a blog. And he also clarified to me stuff about the blog, about how it works. So I wrote down all this stuff here that he talks about. Not all this stuff, obviously, but some of the stuff he talks about. I'm gonna spend 1 hour here today only. And I'll also finish the landing page. Hopefully everything is right, so I don't have to change anything anymore and it works. I tested everything and I made some mistakes when deploying the database, or because when you do it with PlanetScale, that the first time you set up is on the development. They automatically put the database in the development branch, and then after you create the schema and you test it out to see if you're able to put data or remove data from the table, then you can upgrade the database to the production branch. But I created the table, and then also when I was gonna promote to the production branch, I realized that my table didn't have a primary key, and it needs to have a primary key in order to be able to upgrade to production. So I tried that and I realized it didn't have. Then I went to ChatGPT and I asked for the command for creating the primary key, and then I created on the console in the PlanetScale, and then I upgraded to the production branch. But then after making a bunch of changes and deploying the changes to GitHub so that they're updated to the Vercel, I went to test the site on the Vercel, and then I realized that I made a mistake because I just copy-paste the GPT code, and I didn't realize that it was wrong, because I think the way that he was describing is because it didn't put the command explicitly the way that it is. He used like primary key and then table name, let's say, instead of showing the command array. So I think I made a mistake on the substituting the keys for my specific case based on what ChatGPT gave me. So what I had to do is depromote the database again, and then change the schema, and then deploy again, and then thankfully it worked. And now everything seems to be working. And then the other thing that I did after that was to get the link and you put it on the Google Analytics thing here, and then change the documents for the website to have my ID. But that doesn't seem to be working yet. So maybe I made a mistake, but it says there if it's not working, if it has been 48 hours and it's still not working, then you should do something. So I think I'm gonna wait a little bit more to see that, and might not even look into it too much, because I think I'm gonna look into this when I build the blog more, and I think I'm gonna use the Google Analytics alternatives that ChatGPT suggested for the blog and SEO. And also, I think for the landing page, I mean, maybe I focus some time, but because there's so many things to do, I don't think I'm gonna spend a bunch of time trying to figure out how to make the analytics work on the landing page. And also made the copy and things like that, so I'm gonna show now how it looks. And then I think tomorrow I'm gonna start posting videos on TikTok and then putting the link of the page on the video description. But here's the stuff that he talks about. Here he said that you can do a bunch of because each browser has a different fav icon thing. In order to optimize for SEO, it's better to have a bunch of different icons, fav icons for other browsers. So this site allows you to create all of them based on the only one that you have. So when there, and maybe that's another stuff that I'm gonna do. But I think I'm gonna do this on my own time, and you have to put it on the public folder, and he shows you how to do exactly that. Then he also talks about on the videos, I think is this video, managing assets and SEO. This is the video that he talks about this stuff. And this is for image optimization on Next.js. So two sites that you can use to optimize images. And then also about these other things here, accessibility as well, improves SEO. And then the blog stuff that he talks about is that you have something that is called MDX, which is Markdown for the component era. And then you have something called CMS, which I think is Content Management System. And that's the thing that they use on WordPress. And I knew about WordPress, but I didn't know like what's the name of this thing, because I was thinking about when I'm gonna create the blog, there must be a better way to post articles, because I don't understand. People probably have come up with solutions to post articles in a way that is easy and that you don't have to create the HTML structure and CSS all the time. You just create the structure, and then the only thing that changes is the data. And that in one of his videos, he explains, I think he builds the blog and then shows how it works with the MDX. And it's pretty much a component or a library that allows you to write articles with markdown files. And that's the way that they do it. So you can either use that or WordPress as well, which is a content management system. But I think for my blog, I'm gonna use MDX, because I think from as little as I know right now, MDX seems to allow you to do more stuff than CMS does allows. I was gonna say something else about this that I forgot. Oh yeah, he mentions that MDX is more, it may fit you better if you are a developer, and then CMS is more for people that are more from the marketing side. And I think it doesn't mention that he prefers either one. And then he also talked about, I'm gonna look into this Theme UI here as well for the styling, which seems really good. And I looked, there's the two different libraries, Theme UI and Chakra. Chakra, I have heard of it before, but I think is the same thing as Tailwind CSS, where you have a free version that is very limited, and then you have the pro version, which has a bunch of things. And it seems to be very good, but I don't want to pay for the pro version now. So I looked into Theme UI, and seems like Theme UI is open source and it's completely free. So I think I'm gonna investigate that for the blog. And I also copy one of his Git repos to have as a blog example to study and to use that. I think I'm gonna start a blog from that standpoint, because it's he pretty much did all the structure, so it's gonna be very good to study that. Also because of SEO. I'm probably gonna watch all his videos because they're really, really good. And then also he talks about this stuff here, which is called Jamstack. And I've heard the phrase before, Jam, but I didn't know what it stands for. And apparently it's JavaScript APIs and markup, which makes a lot of sense. So whenever someone is talking about Jamstacks, it's probably talking about blogs on sites like that, where you're gonna post a bunch of articles. That's a pretty cool videos, pretty valuable videos. And now I'm gonna show this, and I'm not really sure if I'm gonna study or how much I'm gonna improve the spreadsheets, because I have to start making all these videos here, which is what I'm planning to do today and probably tomorrow, to structure these videos, these other videos on stream, and then film them off stream. And I want to finish this. I think I want to finish all of this before I start the blog. It's probably better because it's gonna be difficult to. So I think I'm gonna decrease the frequency that I upload videos on the other channel, and then that way I can get ahead on these videos here. So hopefully I can stay 3 videos ahead while once I begin building the blog, because that way I have time without posting anything. And then yeah. So now I'm gonna study scope, which I have some idea of what I wanna do, but the challenge is gonna be how to translate what I'm thinking in my mind to the video and how much I can get away with the editing stuff, because I don't have a lot of GPU power, and if I try to do animations, then it crashes. So I can find creative ways to do the editing that I want, but then it takes a lot more time and it's a lot more difficult. So I think the best thing to do is probably not concern myself too much with trying to make the editing and everything too good, and just find the middle ground between quality and quantity. Yeah, so here I followed pretty much the structure that I was talking about before. So I put the desire here, and then for free, and then the pain point, save hours of research, then why this is useful, and then I made a fact there that I'm going to show. And here we won't spam you also. And then this is the stuff that I was talking about that some of the sites do that I thought look good, but yeah. But in this case, it's videos, not images, but I also think it looks really nice. So after spending 2 years of learning how to code on his own while I was streaming the process since they started posting their recordings on YouTube, Dennis Code, he decided to create another channel, teaching people what he learned and master the fundamentals. A very big challenge of learning how to code on your own is understanding the difference between what is fundamental and what changes all the time. These spreadsheets will allow you to gain a better understanding of this distinction. This I'm not really sure about, but I decided to leave it like this because there might be a more simple way to say these things, and it might be better to say it in that way, but I don't think it's worth it right now to change this. You'll be able to compare the 2 different languages and realize when there is a difference in syntax and when there is a fundamental difference in the way the language is structured. Then here I put some stuff that I thought about. I want to read this because I remember putting this stuff here and that I don't have in this spreadsheet yet. And so I'm going to read here to remember so I can study these things. I think it's something about conclusions, and I didn't put the conclusions on the spreadsheets, and that's the last thing that I want to do for the landing page. Is just to improve the lead magnets a little bit, the spreadsheets that I'm going to offer. So I think it's something to do with conclusions, but then maybe I was thinking about something else to put there, so I'm going to read this stuff to remember. So why is this useful? Methods are algorithms. People face the same problem over and over again, so they decided to make the code for the solution as part of the language itself. A lot of them solve common problems, and that's why they were building the language, and they are an essential part of becoming better at a programming language. Being able to compare Python and JavaScript methods not only will allow you to learn them, but also will allow you to understand which ones of them are used most of the time. The spreadsheet has a column where methods are ranked from most used to least used according to VMS. On top of that, you will be able to understand the differences and similarities between both languages, which will increase your ability to create programs and more complex algorithms. How to make the most out of the spreadsheets. The best way to learn from the spreadsheet is to read the conclusions about, this is the thing, about why some of the methods are different on each language, and also learn the patterns. So you are able to understand what kinds of operations are usually done to solve problems. Yeah, that's the stuff I was thinking about. Because it has to be something that is relatively easy to do, but also improves the quality of the thing. So it's something about the patterns that I was thinking about. What can I do to make it better? Because as I was writing this, I was thinking about uh, how to, for people that are learning now, in what way can, because a lot of the times if you just watch videos, you're not gonna remember anything, you're not gonna become better. So how can I get the most out of the spreadsheets as possible? How can I capture the fundamental patterns of each language and through the examples highlight the differences and the similarities? I think that's the goal. But I also don't want to spend a lot of time doing something uh, because if I am going to dive really deep, then it's going to take a lot of time to understand why Python is designed, why there's two different languages in the first place, why it's not only one language. And I think that the main fundamental differences come from data, and Python is more uh, focused on managing and manipulating data, and JavaScript is more focused on the say usability. I'm not sure what's the right word, but the translation of the code into the browser. So it's more focused on the visual aspects, let's say, of on the front end. I think it's more focused on that, and Python is more focused on data. And obviously, this stuff is just my opinion. I can be wrong, and yeah, there's nothing I can do about that. Also, so the spreadsheet I also put there that is just my opinion, and I know most of the stuff I'm probably gonna change my mind in the future as well. The conclusions, spreadsheets. It should be a very effective way to learn because it allows you to understand how to think about programming by giving you an awareness over what is fundamental through the comparison between the two languages. Not only that, but you will also learn a core aspect of the two languages at the same time. Yeah, I think I need to do for each one a different conclusion. But the other issue with doing this on stream is that I don't want to show what I'm gonna write there because then it defeats the point. So that's the difficult thing. So maybe I can go to the documentation again and then remember the methods. I just write something general and then I improve off stream. And the main thing that is difficult is I think I'm just gonna write this stuff that I said before. One of the fundamental, and I'm gonna put on a cell before explicitly saying that it's just my opinion. Just make sure that people understand and they do their own research. And that's the thing that I'm not really sure how to put it in words. Because, for example, JavaScript has methods like the local compare thing that don't exist in Python. And this is obviously because of the browser. So I think there's more optimizations of the language to be translatable, let's say, or for the traveling different places. But I'm not really sure if that's a big difference as well. And then obviously there's those annoying differences in nuances of no, none, and that kind of stuff. But on these spreadsheets, I'm not going to talk about that because they are more focused on the methods itself. So I'm thinking about how are the languages different in the algorithm sense. So another difference I think is that Python is more object oriented. So maybe I can talk about that as well. Maybe a good thing that I can do actually is to study prototypes now. I forgot to put the music. Yeah, that's the stuff that I wanted to study. So I think I'm gonna leave to work on the videos about scope for tomorrow. And then today just study prototypes. Because I think that's one of the core differences as well, is that Python is more object oriented, and then JavaScript has I think is more, it works better with composition, but I'm not really sure. It's hard to put in words as well. Because that's the stuff that I was talking about before, where if I really wanna explain fundamentally the differences between the two, it just takes too much time because then you have to study the source code of both of them and think about how the source code and the interpreter is translating to the machine language, and how that data structure is gonna be, the flow of the data is gonna be different on both of those cases. Because Python, I know Python has multiple interpreters as well, and JavaScript also has multiple interpreters depending on the browser. So not only we have to understand you have to understand pretty much all the interpreters, and then from understanding that, be able to highlight the differences and similarities. And I think it just takes too much time. It's too difficult for me to do that right now. This is a question that I also have, and that I think about a lot, but I don't really know. Because even for me, like, I think the difference between the two is not that big. So I'm not really sure if the difference between languages is more about the community that develops from that language, or if there is a fundamental difference, or if the fundamental differences in the way that the language is interpreted is what makes an essential division, let's say. I think that the two separate languages are far closer in terms of the actual stuff that is going on the hardware. Obviously, there are going to be differences, but I think they're far closer. But then the community that develops around them makes them become very, very different, because a huge part of a programming language is just the community that it attracts, I think. Because the community shapes the language by building the libraries, and that incentivizes people to do certain things with the language, that so it picks up momentum over time. Maybe it's better to use ChatGPT, explore this. Several fundamental differences between JavaScript and Python. Syntax: JavaScript and Python have different syntaxes, which means that they have different ways of writing code. For example, in JavaScript you use curly braces to define blocks of code, while in Python you use indentation. Type in JavaScript is the dynamically typed language, which means that you don't have to specify the data type of a variable when you declare it. Python is a statically typed language, which means that you do have to specify the data type of a variable when you declare. I wonder if that's worth that you put there. Probably not. Execution: JavaScript code is executed in a web browser, while Python code is executed on a server or in a standalone application. Object-oriented programming: both JavaScript and Python support object-oriented programming, but they have different approaches to it. JavaScript uses a prototype-based approach, while Python uses a class-based approach. Standard library. Python has a larger standard library, which means that it has more built-in modules and functions that you can use in your code. Larger standard library. Yeah, I think besides that, what I'm gonna do offstream probably is go over all the methods on the spreadsheet and then see which ones are similar and which ones are different, and then think about the implications of that. Why would that be the case? So another question, for example, is why Python uses a function for the map and in JavaScript is a method. So that is because in JavaScript the array is a class that contains, it's probably a prototype that contains the method of map, but in Python is a function, is a built-in function from the language. So the question is why does this difference exist? Yeah, I think that's a good question to ask. Yeah, but the problem is, I don't think the ChatGPT answer is probably gonna be very good, but maybe it is. I have to think about a better way to ask this question. Popularity, both JavaScript and Python are popular programming languages, but they are used in a different purpose. JavaScript is mainly used for web development, while Python is used for a wide range of applications, including web development, data analysis, machine learning, and scientific computing. Why is map a function in Python? What are the design differences in the languages that it's this distinction? Maybe distinction. I want to study the Python interpreter and JavaScript V8 engine as well, but I don't think I have a time now. Maybe in the future, hopefully in the future I can. I remember studying with ChatGPT, and it shows it's pretty good for that because you can go through the source code and then you can use ChatGPT to ask questions about the files, and then it explains what each thing is, and then you can obviously go to the source code and see. It becomes easier to create a hierarchy of importance of how you're going to navigate the structure of the project. In prototype-based approach, objects are created by cloning existing objects, rather than by defining a new class. This means that you can create a new object by copying an existing object and then modifying it to suit your needs. In a class-based approach, on the other hand, objects are created by defining a class and then instantiating it to create new objects. The class defines the properties and behaviors that will be inherited by the objects that are created from it. Here are some key differences between prototype-based and class-based approaches. Inheritance. In a prototype-based approach, inheritance is implemented by copying properties and behaviors from one object to another, rather than by defining classes and subclasses relationships. In class-based approach, inheritance is implemented by defining classes and subclasses relationships. Properties and behaviors. Yeah, so it is that stuff that I was talking about, that I think because of this, JavaScript incentivizes more composition and Python incentivizes more the object-oriented way. And I think Python, in Python everything is an object, I think. So there's also an analogy, or because everything, I believe at least, that everything is a symmetry, is a relative symmetry. So it's actually a multifractal symmetry, converging in symmetry, and it's relative because time is always changing, so it's not a fixed state, so it's always entangled with the experience of the observer. So, but what that means is that you always have the polarity of the feminine and the masculine. And one of the things that I realized when I was studying programming is that I think that a good example of this is databases, where you have SQL databases, which are the more masculine form of database, and then you have NoSQL databases, which are the more feminine type of database. And then I think that the blockchain might be in the middle between the two, and that's why the convergence towards the equilibrium is there, because that's how the change in complexity happens over time, through decreased entropy, because that increases information. Through the friction between relative polarities creates the change in information. So there's always this movement, the pendulum of movement between these two, this spectrum of energy. So NoSQL is more feminine because it incentivizes more potential and chaos because it allows you to spread. It's easier to spread, let's say. And Escalao is more masculine because it's more rigid and is vertically integrated, I think. So I assume that there is an analogy here, and I think the way that I see Python and JavaScript is being a part of the symmetry, and C++ is the bridge that the bridge between them. And that's the evolution of programming as well, where you have the branches of the game tree increasing over time, through specializing in relationship to the complexity of the environment that exists. So everything works, everything starts from the binary, the hardware level, and then over time it creates this tree structure according to the information, which depends on the environment, because it's created by concepts. So there's probably an analogy here, or where Python is either masculine and JavaScript. I think Python is more masculine and JavaScript is more of the feminine, in the way that I'm seeing this right now. So what that means is pretty much that Python incentivizes more rigidness, let's say, and JavaScript incentivizes more potential, and chaos is more volatile. But obviously I'm not sure about that, so I can change my mind, because I have no idea if that's the case or not. But it seems to be that way. Maybe I'll put that on the spreadsheet, but I'm not sure if it's worth it. But I think I'm gonna put it because there's it's not like people are gonna lose anything if I put this stuff there. Maybe I'll put it on another section. Modifiability. In a prototype-based approach, it is easy to add or modify the properties and behaviors of an object because you can simply modify the object itself. In a class-based approach, it is more difficult to add or modify the properties and behaviors of an object, because you have to modify the class definition and then create new instances of the class to see the changes. Okay, let me read that again, because I was thinking about the other stuff. In a prototype-based approach, it is easy to add or modify the properties and behaviors of an object. Yeah, so it is the stuff that I was talking about. So JavaScript is more volatile and it has more potential, and then Python is more rigid and has less potential. So I think that's the reason why, and that's probably has to do with the way the server and the relationship between the server and the client work, and the communication between the two, because it probably works as a funnel of information, just like everything else, based on gravity. So yeah, the backend is like an inverted pyramid, let's say, or the backend is more, or maybe it's a normal pyramid. The backend is more stable, and then once you go through the front end, it becomes the top of the funnel, where, or maybe it's the other way around, because the way that I think about hierarchies, the base layer has more potential and chaos, and then at the top you have more order. So it's probably the other way around, but I'm not really sure. Yeah, like the database is the points, so it's an inverse pyramid where the backend is the point, and then as you grow you have more complexity, so you need more versatility. That's the difference, because if you have a bunch of different businesses and a bunch of different businesses have different goals, then the language has to be more versatile to accommodate for the different cases of the way that you have to translate the data into different formats. But for the backend, it probably changes less because it's more related to the patterns that they are more constant across time. But obviously it's not gonna be rigid 100% of the time, because these things are always relative and they are always changing. But it's a flow of information, I think. Simply modify the class approach. In a class approach, it is more difficult to add or modify the properties and behaviors of an object, because you have to modify the class definition and then create new instances of the class to see the changes. Yeah, so if you remove all the concepts, then it becomes about the data, and the data is geometry. So I think that's something good to think about, because it allows you to understand the difference in what's fundamental and what's nuance. And I was also thinking about the other day that this is pretty much the point of scientific thinking, I think, where because there's never answer, everything is always changing, so the flow of information is to find, I forgot what I was gonna say. To find what? Yeah, completely forgot. Yeah, I'm not gonna remember. So, encapsulation in a prototype-based approach, it is harder to achieve encapsulation because properties and behaviors are not grouped together in a class. In a class-based approach, it is easier to achieve encapsulation because properties and behaviors are grouped together in a class. I was talking about science. What was I gonna say? Oh yeah, because there's this relationship between subjective and objective. That's what I was thinking. But I forgot exactly what I was thinking about. Yeah, because higher density of observation makes things more solid, and lower density of observation makes things more fluid. And that's the relationship between the masculine and the feminine, and that's why they are entangled. So that's why it's a relative distribution, because if you can only have facts if you have the potential for non-facts to exist. So that's the symmetry between lie and truth as well, that I think is the case, where truth is matter and lie is potential, and they are always entangled because you can't have potential if you don't have matter, and you can't have matter if you don't have potential. So the answer to the question why is there something rather than nothing is because something is nothing. So nothing is the potential and it's the feminine part, and something is the masculine part, which is matter, and they are always entangled in that way. And that's the why. So it is a symmetry, but it's not symmetrical at the same time. So it's a paradox, and that's why it's always changing. But the patterns of information have these characteristics, and I think it's all about becoming better of understanding this. Is all about finding the relative symmetries in order to compress the information and to learn faster, which is what I'm trying to do here. So the question is how to compress this, or how to find the distinctions between these things, and in a way that allows me to simplify the learning process for other people. Yeah, so I'm trying to think about questions that, without having to research a bunch and lose a bunch of time, that will allow me to understand this difference between Python and JavaScript, from this stuff that of the feminine and the masculine that I was talking about, to understand the flow of information. So it probably has to do with the ways that they access memory as well. Because memory is shaped in the funnel as well because of the thing that I was talking about. So it is the reason why SQL is that symbol of a cylinder is because that was the physical shape of the way that they stored memory. So these things are a physical thing. And so there is always this trade-off between, so computing is all about manipulating the state of space-time in relationship to the electromagnetic field. So the geometry of an electromagnetic field in relationship to space-time, and that creates the funnel of the memory flow, which is SQL at the bottom, or hard drive at the bottom, and then RAM, and then the cache. So the faster you need the information, the less space you have, and then it creates this funnel shape because that's the most efficient flow of information. And that's why societies are a hierarchical structure as well. So the differences in languages are going to be analogous to this mechanism of the structure of the data that they're built upon. But it seems like they are both at the same level of abstraction, so the difference must be on the flow of information, so how they manage memory. And I think probably the difference between all the languages is just the way that they manage memory. The rest is just syntax, probably. So the question is, why would Python be better for managing, or not better? Like, how can I ask this? What kind of memory is Python more incentivized to use, let's say? I think the fundamental thing that I'm trying to understand is the stuff that I was talking about before of which comes first, the language or the community. So what's more important, that the language is structured in a certain way that's going to create a different community, or the languages are not that different, and then the community creates the language that way. Because I think this difference will allow me to ask the questions to understand what are the differences between them. Because there is a chance that if it is the community that creates the language based on the libraries, then there's a chance that the community is wrong, obviously. So I think that's why the distinction is important to understand. Because I thought about this, where it seems to me that Rust would be better for something like machine learning, for example, or even C++. But Python is the one that is most popular, and they say that Rust and C++ seems to be better because they're faster. So, and because you need the bigger the machine learning model, the more data, the more computation you need to have. So it seems to me that it makes sense that the faster language would be better. But then there's obviously the trade-off of the developing time. So, but that's the thing that is difficult to assess. Like, why not use JavaScript for machine learning as well? So how can I ask a question that is going to allow me to understand, or to give me a good output from ChatGPT to understand this fundamental difference? Or is there even a very big difference between them? I think so far, based on these assumptions, I think there is, and it makes the stuff that I'm saying makes sense. That JavaScript is more of the feminine energy, and Python is more of the masculine. So yeah, but what if that's the case? What would be the implications? That's the question. Python functions are first-class citizens, which means that they can be treated like any other object. This makes it easy to pass functions as arguments to other functions, and to assign them to variables. JavaScript functions are also first-class citizens, but the language has a more object-oriented design. And so it's the other way around. With a focus on prototypes and inheritance. As a result, many of the built-in array methods, including map, are implemented as methods of the array object, rather than standalone functions. Well, the main difference between the Python and JavaScript versions of map is a result of the different design philosophies of the two languages, the way they handle functions and objects. Rich language is more objects oriented. Python. And didn't know that. This means the Python code is executed by the interpreter line by line, while JavaScript code is first compiled. Oh, I think I remember studying the just-in-time compiler thing. I didn't remember this. It means that Python code is executed by the interpreter line by line, while JavaScript code is first compiled with machine code by the interpreter and then executed. Another difference is that Python has a global interpreter lock, which prevents multiple threads from executing Python's bytecodes simultaneously. This is done to prevent conflicts between threads that might try to access shared resources. JavaScript, on the other hand, does not have a GUI and can run multiple threads concurrently. As far as optimization, interesting. As far as optimization is concerned, both Python and JavaScript have their own trade-offs in terms of memory management. In Python, their interpreter automatically manages memory allocation and garbage collection. This means that Python developers don't have to worry about manually allocating and freeing memory, which can be convenient. However, the automatic memory management in Python can also lead to slower execution, because the interpreter has to continuously monitor and manage memory usage. JavaScript developers have more control over memory management because they can manually allocate and free memory using techniques such as manual memory management and garbage collection. This can give JavaScript code more flexibility and can potentially lead to better performance, but it also requires developers to have a deeper understanding of memory management in order to use these techniques effectively. Overall, the differences in the interpreters of Python and JavaScript can have an impact on the performance and optimization of code within these languages. The trade-offs in terms of memory management depend on the specific needs and requirements of your project. I'm trying to associate this with machine learning. There are several reasons why Python is used more frequently for machine learning than other programming languages: popularity, ease of use, support for machine learning, flexibility. Yeah, but this is the thing. Is it just because of the popularity and easy of use? I don't think I'm gonna go on this thread because then I'm gonna lose focus on what I'm trying to do now, which is clarify the differences between Python and JavaScript. Is a mutex that protects the interpreter's internal data and structures from concurrent access by multiple threads. It is implemented in Python to prevent conflicts between threads that might try to access shared resources simultaneously. One reason that Python has a GUI is that it was originally designed as a scripting language, which means that it was intended to be used for simple single-threaded programs. The GUI was added to Python to ensure that multiple threads could not interfere with each other and cause unpredictable behavior. I think there is definitely a correlation between this and the way that machine learning is. I shouldn't say definitely, but because I'm not really sure, but that's what I'm assuming now, based on this stuff. The thing is, eventually everything becomes machine code, so... But I think it does matter because the processing of the information also changes. But machine learning is just weights and biases, but I think it does have... Because an AGI or a more advanced system, I think, would have... You would have to constantly change and learn over time. You wouldn't... Because if machine learning is only doing the training and setting weights and biases, and then never changing it again, then it's never gonna be AGI because you're fixed on that state. And I think that's the thing that is lacking on the machine learning thing. Because the models are very good, but they are just they're fixed on the data that they're trained. As far as I know, obviously, I don't know a lot, but... And this might be one of the reasons, because Python incentivizes more this approach, or the data. Maybe there is this connection between the way that the data changes and the way that they look, languages structure. I think there must be a difference. Must be a connection, I think. Because if you think about it, all that the languages are doing is manipulating data. So it's everything about data at the bottom, and the only differences between them is the flow of the data over time in relationship to the space that they are changing the information. So the optimizations are done based on these trade-offs, and these trade-offs happen because of the data. So the language structure has to be connected with the flow of information, which is the flow of the data. So there's probably something there, I think. One reason that Python has a GUI is that, okay, I think I read that. JavaScript, on the other hand, was designed to be a multi-threaded language from the start. It has support for web workers, which allow developers to run JavaScript code in separate threads. Because of this, JavaScript does not need a GUI to protect its internal data structures from concurrent access by multiple threads. Overall, the main reason that Python has a GUI and JavaScript does not is that Python and JavaScript were designed with different goals and use cases in mind. Python was originally intended as a simple single-threaded scripting language, while JavaScript was designed to be a multi-threaded language for using web browsers. Maybe we can ask, how did these differences influence the fields and algorithms? Another question that I have is, why don't you have the same algorithms on all languages? Because if you can achieve the same thing on all the languages, why don't they have the same algorithms? I guess that would make it, because Python you have to download, and JavaScript you don't, but then you do actually, because you're either using the browser or using the Node.js. So I think the only reason why would be because of this difference in optimization between the two. To not put the methods with the language as well. But it's not like it would make a significant difference, I think. Yeah, but that's the thing that is hard for me, because I think most of these things is just they are not fundamental differences, they are just differences because of the way that human beings interact with each other. So it's kind of hard to tell. It's the same problem that I had. It's like I'm going full circle, but now I'm on a different place, which is the same problem I had in the beginning, is trying to understand from the syntax what is fundamental and what is not, and was the thing that I found the most challenging, which is I didn't understand that when I type something on the file and the computer is actually gonna put meaning on that, and when it's not gonna put meaning on that. And that was it was a very big difficult thing for me to understand. And I think the same thing is happening here again, but it's on a different situation. Which is to try to understand this distinction of what is fundamental from the languages, about the evolution of the languages, what actually came because of physical things that are necessary or that were optimized because of that, or that came because of politics and the evolution of group dynamics. Because if you have different cultures and different communities, then the technology evolves differently because of that. And it's probably in the middle way, but then the more politics is involved, the harder it becomes to actually describe what exactly is the difference between them. Because I guess if the answer is that is more because of politics, that they are different, then there shouldn't be a reason why for people not to build the same algorithms in both languages, because if they are very similar, then why not they just make the syntax as similar as possible? But if the answer is more that there are fundamental differences, then I think it makes sense for the algorithms to be different, because embedded on the syntax that has the meaning, has all the differences and nuances that of the way that the flow of the data is gonna change. The differences between Python and JavaScript, such as the way that they handle typing, inheritance, and memory management, can influence the built-in algorithms and methods that are available in the two languages. For example, Python is a dynamic type language. It has built-in methods for handling variables of data types such as lists, dictionaries, and sets. JavaScript, on the other hand, the other thing is I forgot to talk about sets as well, but now I think it's too late. I forgot about it completely on the previous videos. JavaScript, on the other hand, is a weakly typed language, which means that it does not have as many built-in data types. Similarly, because Python uses... So I'm gonna copy this. I'm not gonna copy, I'm gonna write it down, I think. Because Python is weakly typed, it doesn't have as many built-in types. So this brings me the question of why Similarly, because Python uses a class-based approach to object-oriented programming, it has built-in methods for defining and inheriting from classes, such as the class and super keywords. JavaScript, which uses a prototype-based approach, does not have these types of built-in methods. In terms of memory management, the fact that Python has a GIL and automatic garbage collection can influence the types of algorithms and methods that are available. For example, Python may have built-in methods for parallelizing code across multiple threads, but these methods may be less efficient than equivalent methods in languages without a GIL. Overall, the differences between Python and JavaScript can influence the types of algorithms and methods that are available in the two languages, and can affect the performance and behavior of code written in these languages. So I think I can write down here that one seems to be Python was designed for single thread. JavaScript for a multi-thread. Sure, Python is strongly typed, and no, Python is weakly typed. JS is strongly typed. So this seems to be the core two fundamental differences that make the differences in methods and syntax and the evolution of the language. And also the memory management thing of the garbage collection, but yeah, I think by JavaScript you have more degrees of freedom to manage memory. There's something else here as well. Garbage collection is something else. Manually allocating female. Control over. Yeah, I think that those three are the fundamental differences, it seems like, from these answers from ChatGPT. And then everything else probably is an evolution around that, I think. So the community builds programs based on those differences, and then that shapes the way that the language is. Obviously, we still have a lot more to learn. Why being weakly typed incentivizes less built-in data types? In a weakly typed language such as JavaScript, variables do not have a fixed data type, and the interpreter will automatically convert the value of a variable to the appropriate data type based on the context in which it is used. This means that you do not have to specify the data type of a variable when you declare it, and you can assign values of different data types to the same variable. Let me read this again. So in JavaScript, variables do not have a fixed data type, and the interpreter will automatically convert the value of a variable to the appropriate data type based on the context in which it is used. This means that you do not have to specify the data type of a variable when you declare it, and you can assign values of different data types to the same variable. So it's more dynamic in that way, because you can use one variable for multiple different cases, and in Python you have to specify, and that's why it's more rigid. So I think that the stuff that I was saying makes sense about Python is more masculine, JavaScript is more feminine. So JavaScript has more chaos and potential. JavaScript is more structured. Python is more structured, but it has less flexibility. Maybe I can also study, but I think that's gonna take too much time, but I do wanna do that, which is study the design decisions, like not only the methods, but in which patterns the methods are used the most. I know personally from the stuff that I've done, which I'm not really sure if it's probably not very optimized, because I'm not very strong when it comes to data structures and algorithms. But the stuff that I've done, the things that I use the most are a loop and then control flow inside of the loop. Or if-else statements, because loops are control flow as well. So control flow, and then something, then objects and obviously the methods in objects as well. So this seems to be the patterns that I use the most. And then obviously functions when you want to encapsulate the code. Yeah, the stuff that I'm thinking about talking on the scope video is gonna be, because the analogy I was making in my mind is that a program is like a city, and then a file is like a neighborhood, and the functions are like the houses. So if you have a bicycle inside of the house, and you leave the bicycle outside of the house, it's more likely that someone's gonna steal that bicycle. So that's, depending on the use case, that's not very good. But then you can also have the postman, and the postman uses a bicycle to deliver packages for people. So in that case, it might be better to have the bicycle on the street because it's serving a purpose. And that's the difference between the scopes in functions. And that's the purpose of having functions, is this scope is analogous to walls in a house. So they are the walls of the structure. Yeah, but going back to this, I also want to study what are these patterns that are used the most. But I don't think it's necessarily software design, because I'm not talking about, maybe it is the same thing, but I'm talking about the middle layer, I think, between the software design and I think it's just algorithms, data structures and algorithms, where you have the patterns of the way that they should solve. So you have backtracking, and then graph and tree problems and things like that. But I want to understand more what usually what kind of methods are used on these algorithms to solve these problems, I think. But I think that's not gonna be a good thing to incorporate now, because I don't have time. So, and it would be better to study this stuff if I'm going to make videos about data structures and algorithms, which I'm not sure if I'm gonna do or not. Maybe I'll ask 1 or 2 questions now, and then I'll decide if I put something like that. I know that also in JavaScript, map and filter are used a lot because you want to display things in the browser. So I think I can talk about this. Usually when you're using a framework, then you can you're gonna use filter and map very often to display data on the browser. Weakly typed languages such as JavaScript variables, blah blah. Yeah, I don't think I'm gonna study this stuff. I don't have time. So I'm just gonna what I'm gonna do is go from these 3 main things here, and then I'm gonna elaborate into the text, into conclusions on 3 of the files in the methods. I think I'm gonna do this probably tomorrow, actually, because now it's already late. And tomorrow on the stream, I'm gonna create the scope, the video for our downloads, or get the images that I'm gonna use, and then create the structure probably on Skylidraw of what I'm gonna talk about. And then I will finish this stuff for the spreadsheets. And I'm gonna elaborate, I'm gonna get these 3 main differences here. And then I'm gonna look at the spreadsheets, and then I'm gonna try to expand like a branch, like a tree, going from the top with which is the main concept, and then writing down based on the specific algorithms of each spreadsheet, what are the differences, how those fundamental differences translate into differences in methods from both languages, differences in similarities in methods from both languages. So very probably 80% chance that I'm gonna come back tomorrow and do work on this